Hello and welcome to another episode of Deep Dive into Applied Science. My name is Martin Seng, I'm your host, and today I have a very special guest for you, and this guest can introduce himself.
Yeah.
Over to you.
Hi, my name is Maximilian Staudt. I'm currently the PhD student here in the Department of Food Engineering, and I hope we have a nice discussion about my topic and bring you the concepts of my thesis a bit closer.
So, before we dive deeper, please describe your project in one sentence, if possible.
Yeah, that was a really great question, Martin. Thank you. I thought about this quite a lot, and I go with a possibility to reduce energy usage while trying.
So, the whole title of your project is the determination of depth profiles using angle-resolved near-infrared spectroscopy. That's a very complex title.
Yes.
So, what exactly is behind this title?
In first glance, you can imagine it like you or I try to find a way to determine water content in a very close surface area of a sample, in my case, foodstuff, like pasta plates, for example, if you want to make lasagna. To a certain extent, you go maybe with powders as well. Powders is like a huge part if you think about protein powders, and most of the ingredients used in our modern foods come in powder. So that's the main focus, to find the water, and the goal is to reduce, with the knowledge of where and how much water is inside the food, to reduce the drying times by checking exactly where's the water and then applying the perfect drying technique for this the point where the water is.
Before we come to the drying of the water, why is the location of water such an important topic? Why do I have to know where water is in food?
Usually it's like you try something and a lot of energy and knowledge goes into how to increase shelf life of food. So trying is a very important process step in increasing shelf life. But it's also very intense in energy usage. So usually to stay safe, you try longer than needed. So that's where I come in place. While showing, okay, there and there is that much water, we can determine the right time, like the perfect time for the drying process, so that we don't need this extra time, like the safe time. And this time, the savage in time also means a savage in energy use. Because drying is not like, with more time you dry, the harder it gets to get the stuff dry, the more energy you need. So it's very important to keep the time as short as necessary. Mm-hmm. That's the goal. And you also can use it not only for food, but also in plastic or even in clothing. Mm-hmm. So everywhere where drying is applied, but one limitation is like the penetration depth of the mechanism behind the angle-resolved NIR spectroscopy.
Your research, does it focus on both aspects, on the drying and on the location?
Less on the drying, more on the location.
Okay. And can you recognize water in any type of food, or is there only very specific types?
It's depending less on the food, more of the penetration depth. Like if you have a product that is very, very huge, very big, then it's very unlikely. The method I'm using just penetrates the sample to a few millimeters. So there is a limitation where you can use it. So like pasta plates is like the best way to understand it, because you have very tiny, very thin plates. They are not thick, and then you pretty much can use this method very, very easy.
So you try to locate the water with a so-called near-infrared spectroscopy. What exactly is this?
let's start with the spectroscopy part, just for better understanding. Generally, spectroscopy means you measure the interaction of matter with light. So, in my case, using NIR, it's
That's the short version.
for near infrared. Maybe to better understanding, to see light as a electromagnetic wave from 2, and we humans see just in a certain range. That's the visible part, and right next to this visible part is the near infrared light, the infrared light, and you can separate it in near, mid, and far infrared. And I'm using near infrared. So I'm using the near infrared part of light and see the interaction with the matter. And after this interaction with the matter, there are certain informations hidden in this changes in light that I can use to interpret it, certain informations. Generally used for the total water content, total fat content, or total protein content. So it's a technique that's around for like 70 years. Mostly used or mainly used by American companies. Like there's more the focus in this regard. It's a very easy way, a fast way to find like this macro food contents. And what I'm doing, I'm not trying to find the whole water, like if we have a sample. By now it's used to find, like in the sample, the entire water content, and I try to look for the fine locations of the water.
So now that we know what NIR is and how it works, how exactly do you visualize the location of water?
There is a neural network, very helpful. A neural network is great for pattern recognition. Imagining you have your favorite dish from your grandma. Like you know the ingredients and you know how it tastes, but you don't know how she cooks it. When do she mix stuff together, and just how the process is that she makes to get your favorite dish. And so you know the ingredients and how it tastes. Then the neural network is great for this, to find the way from your ingredients to your dish by trying. Simply by trying around and adjusting things inside the neural network, and then you got the result. So now it's the thing with the neural network, you have more than one result. You need more than just one result. So then you bring other stuff inside, other foods, like your favorite pizza, your favorite burger, everything. You know the ingredients, you know the result. And by giving all this information, the neural network will find the pattern, and then you have a cooking network in the end, because it now finds out how to cook certain ingredients, what suits together, but therefore you need like a lot of informations. And my ingredients, so to speak, are like the graphs I receive from the NIR, the water content where I know where it is because I use the 3D printer. So I have a 3D image of my sample, so to speak, and I know where the water is and how much is inside. And with this information, I try to visualize the stuff because I know I got the result and I got the information. So I model the neural network to go from my information to my result. That's a very tough part. And by now I don't really know which types of models I can use, I can try. Or is it one model? Is it more? How much information do I need? That it's like the next step that will be coming.
Sounds like a very complex process overall. You mentioned your neural network and that it needs a lot of data. How much data exactly? Can you specify this?
Before I started, I can't really tell you how much data I need. Mm-hmm. I just see there will be a point where it's like don't getting better. So if you have your neural network and you trained it, and then you go there with an unknown result, unknown things, and then you see how it responds to this new information. And with this validation, you know how good your network is. And then with a few mathematical things, you can get a percentage of how good your neural network is. And then it's deciding not only the information is important, also the way you model your neural network. So it's I can't give a direct number by now. I will see it later on. And it's also depending on how good my results are from the neural network.
You already mentioned that you are working with a 3D printer. So the Department of Food Engineering and Technology is by far not the only department that's using such printers. But how do you exactly use a 3D printer in your project?
Using the 3D printer, there are two ideas behind that. First of all, during my measurements, I need to make sure that my samples are stable. So that there are no dynamics, no changes, like water could dry. And while I'm measuring, that could change the results. So that's one thing. Like I create with the 3D printer a stable sample. And on the other hand, I have in the program, I got my my set of for the spatial visualization, hard word, and I need this because it's already made in a computing environment. So neural network doesn't know a picture. Those concepts are strange to it. They don't understand it. You need to translate it in a way that the computer can find patterns. So giving it a picture won't mean much anything. But in a 3D printed area, you also have it in an algorithm or something like that, in a program. And a neural network can work with this program. And in this program already are my informations. Where are the spots where the water later on is supposed to be? So I got my result in this information. And because I use a neural network and I train it, I need the result in the end so that I can use this pattern recognition method. And that's the reason why one method to train my neural network was the idea with the 3D printer.
Since your project sounds very complex, not only with the 3D printer, also with the neural network, do you work alone or do you work in a team?
The first year I worked alone. Now I have an internship from Italy. We are working on a second method for a second result if you want to. So now my results from my neural network came from the 3D printer. And we use another technology called NMR mouse. It's another kind of spectroscopy that don't bring us like a visualization, because if you ever used a CAD program to create something into a 3D printer environment, you see the stuff you create. There we have more like an abstract way. We have a graph. Not a problem, because you also can try to find a pattern between your information and a graph. The advantage of this idea is in the industry you don't usually know your stuff. Like if you have your pasta plate, don't know where it is. This way is just if it's working with the 3D printer, I assume it would work with other methods. Like the other method is the NMR mouse. It's there are plenty of methods, but that's one we have here. So then we can actually create a method that could be directly used in the industry.
That's a very good point, because once you finish the project, what are possible fields of application for your project? In what areas can your research be used? Who can profit from it?
Pretty much everywhere where drying is used to a certain extent. I mean, I got the limitation of this, just the light penetrates like a few millimeters inside the surface. Mm-hmm. So I'm limited by drying products that are just thin. The good thing is with drying, usually you have thin products. Like plastic, pasta, protein powder, other powders, they're very thin. So pretty much in a lot of drying environments. Maybe even in other situations where you can't think of. Maybe even here, if you say, we have a nice desk here, wood and glaze on top, and you want to see if there's glaze in the water. Then you can say, okay, maybe this won't dry as good. So you could use it in such an approach as well, but mainly it's meant for food.
So you're not limited to the food industry, but, well, you focus on it.
Because we are here in the food department, but there are usage outside the food.
And please correct me if I'm wrong, but it sounds like almost everyone in the food industry could possibly profit from your project.
If they have this tiny fraction or this thin samples, then they could, yes. And the good thing is with NIR is a cheap way, is widely spread, and you can do it while you're making the process. It's online.
So one thing I ask myself, since I've actually never heard of this project, are there similar projects, or are you like forerunner in your field?
So and so. Like the neural network part and using an NIR is something that has been used before. There are quite a few papers regarding about this topic. Using the anchor resolved method is something new. That's the different approach in this entire topic. Maybe we come to this anchor resolved, why it's that important. I said earlier, for neural network, you need quite a lot of data, quite a lot of measurements. Now, if you are in the food environment, you have like 100 samples, you measure them, it's not enough to make a neural network. The anchor resolved approach means the measurement is taken from different angles. So instead of taking one measurement per sample, you take like 100. So the amount of information you got to train your neural network increase. That's the main part and the main idea behind this anchor resolved thing.
When exactly did you start this whole PhD project?
Pretty much 1 year ago, on the 3rd of April. So it's really, really close, like a year ago.
And you plan on finishing when exactly?
It should be done in 2 years from now.
I don't expect a perfect deadline, don't worry. Okay, interesting. Also, a question that really interests me. Which obstacles did you face so far? What are the challenges of your project?
Especially in the first year, and I talked with other PhD students about it, what I didn't expect is like getting this stuff together, working with this bureaucratic environment is something you get used to and takes quite a lot of time. And then if you go off this more into the science stuff, the first samples I created, they needed to be stable. And for being stable, I tried a lot of things with my samples and noticed, okay, no, that's not the approach.
So basically trial and error.
Trial and error to find a way to have my samples stable. For example, the samples I got now, I won't use them for my measurements. Like the new edition that I'm making, they should be stable. I mean, I obviously will know it after the results, but I'm more confident because all the information I got working with them flew into in the construction of the new ones. So I assume that with the newer samples, I can create my informations, my measurements. Another thing that was hard, because I'm working with neural networks, I'm working with CAD programs to create my samples, working with an IR, and also the angle resolved positioning system. So that's like 4 types of systems I'm working with, and with all of them you need to get used to, and to a very certain extent that takes quite a lot of time. And especially, I'm a food engineer, not an informatic. So I'm not an IT guy. If you want, I'm from the IT department. So getting into the neural network, the programming, and so took quite a lot of time as well. Yes, that's what like the biggest obstacle.
Since we're already talking about Trier University of Applied Sciences, you already completed your bachelor's and your master's thesis here at university. So why did you choose to do your PhD also here? Why didn't you choose to go, I don't know, to Luxembourg or somewhere else?
I had this my master thesis in Luxembourg, and I had the chance to work in this company where I wrote my thesis. The problem is or was getting to the company, first of all. Second of all, I know the Hochschule because I made bachelor masters here. I know Trier. I love Trier. That's the reason why I wanted to stay close, and I hope that I can bring something to the portfolio of the Hochschule Trier in general. And so it's a mixture between I know where I am, I know the people, so I hoped it was like a plug and play situation. I expected that I don't need much time to get to work. Then I noticed a few obstacles that we mentioned before.
Well, sounds like you're adding a lot to the portfolio of Trier University of Applied Sciences. So if people are interested in your work, in your whole project, how can they contact you?
Yeah, they always can contact me by mail or on the Hochschule website there's the phone number, the mail address. And if you wanted to see a bit more, there is a colloquium of projects from the Hochschule, from the University of Applied Science. And there you can find my project as well. And by time, the informations will be updated on the website as well.
Perfect. Thanks for letting us know. So it sounds like an overall very interesting project, even though very complex, especially the overall title of your project. But still, I think it's a really interesting work, and it looks like you have a lot of future fields of application for this. So thank you very much for presenting it.
Thank you for having me here.
And I hope our listeners or viewers had a fun time. And if you still have questions for Maximilian, feel free to ask them, feel free to contact them. And we will see each other in the next episode of Deep Dive.